200,000, 9,000. So what I like to do is to write the numbers down. So 200,000, I'm going to write this down. 9,000, stack them up, and then 200s and 2. Then from here, just add carefully, place value by place value, and there you get the answer. For this, long division can be used if you want to, but let me show you what I do. So I break up the numbers into as large multiples as possible. So 700, yeah, divisible by 7, very nicely. 42, very nicely, with a remainder of 0.5, okay? So from here, I can determine that this is 106 right here. And because there's a numerator with a decimal, I'm going to times 2 and times 2. I get 1 over 14. So what I can do at this point is to just take 1 divided by 14. I don't have to worry about the whole number portion. So 1 divided by 14 is 0.07. And because we want up to 1 dp, we stop at the second decimal place to see if we need to round up or keep it the same. In this case, we have to round up because 7 is larger than 5. So in this case, it will go from 106.07 to 106.1. Question 3, of points to the denominator. So I know that this is the numerator and this is the denominator. So here we go, 40 centimeters, 2 meters, convert both to centimeters, cancel 1 0 from the top and bottom, you get 4 over 20, then you divide by 4 and for each side, and then you get 1/5. Find the value of 3/4 divided by 1/12. So what we can do is 3/4. Now change division sign to a multiplication and then flip 1 over 12 to 12 over 1. And then we simplify diagonally. Divided by 4, you get 1. Divided by 4, you get 3. So 1 times 1 is 1. So nothing to do there. 3 times 3 is 9. So the answer is 9. A machine can print 70 cards in 3 minutes. How many in 1 hour? So what I can do is to say, alright, 3 minutes, 70 cards. 1 hour is also known as 60 minutes. So from 3 to 60, I can simply multiply by 20. So do the same on the right hand side. 7 times 2 is 14. Add another 2 zeros, you get 1400. Find the area of the triangle, which means I have a 90-degree angle right here. This will be the perpendicular height, and the base will be 4 times 8. So let's do that. So half times base, 4 plus 8, times the height of 3. So what you can do from here is to say, alright, this is half times 12. Half of 12 is super easy, that's 6. 6 times 3 is therefore 18 square centimeters. ABCD is a square, alright, so I've got a diagonal of a square, which means I've got 45, 45, 45, 45. A few more things, I can tell that these two angles are the same because we've got parallel lines AD and QT. So these two are corresponding angles, they are the same. So let's go through which one is not true. First one, QT is parallel to BC, absolutely, yeah, because I've got 90 degrees here, and this is a corner of a square is also 90 degrees. So these two are parallel, so that's true. QT is perpendicular to DC. Well, if this is 90 degrees and this is 90 degrees, therefore it is still the case. This is a true statement, number 2. Next one, angle DUT is equal to UDT, right? That is also true because this is half of a square diagonal here, right? This is 45 degrees. Now, if this is a right angle, then this must be 45 degrees as well. So this is an isosceles triangle, absolutely true. So let's see if the last one is the one that's not true, the one we're looking for. ADU is this angle right here, plus QUB is 180. No, that's not true, yeah? So the answer is number 4. Partially filled with 1 cm cubes. What's the volume of this entire container? Well, before we do that, let's count the sides, the length of the side, shall we? So along the breadth, we've got 1, 2, 3, 4, 5, 6, 7. There's an 8 hiding over there, yeah? So the length here is 8. Now, what's the breadth? So it's 1, 2, 3, 4, and there's another one hiding up there, okay, hidden from there, so that's 5. And next one will be 3. Why? Because 1, 2, 3, that's the height. Now, the volume of 1 cube is therefore 1 times 1 times 1, since it's a 1 cm cube, right? That's 1 cubic centimeter. Now, how many cubes do we have altogether? We've got 8 by 5 by 3. So each one of them is 1 cubic centimeter. So 8 times 5 times 3, we've got 40 times 3, which is 120 cubic centimeters. Question 9, symmetry. So let's make sure that we've got a mirror image on the other side. So with this app, I'm able to do this, right? So just make sure that this here is reflected here, the one further away, another one further away, 2 blanks, okay, and then fills, and then closer to AB, closer to AB. So the mirror image is generated with number 2. Kelly was facing southwest, she turned, okay, Kelly was facing southwest. How about we draw this, right? She was facing southwest. She turned 315 degrees anti-clockwise. Anti-clockwise would be going this way. Now, I like to break up 315 to 270 and 45. So this is 3 quarter turns. That's 90 degrees, 90 degrees, 90 degrees. I'm going to draw an 8-point compass and show 3 90-degree turns anti-clockwise. 1 quarter, 2 quarter turns, 3 quarter turns. And then 315 is made out of 3 quarter turns and a 45 degrees. So 45 degrees is half of a right angle like this. So the answer shows that she ended up facing west at the end. Now. Using all the digits, form the largest multiple of 5 between 1,000 and 8,000. Well, largest possible between 1,000 and 8,000. So I know that this is largest as possible, but it cannot be 8,000. It's between 8,000. It's less than 8,000. So it's probably a 7. Yeah. Last digit determines whether it's a multiple of 5. So it's either a 0 or 5. I've got no 0, so it has to be 5. So let's fill in the numbers here. It's largest possible. That's under 8,000. That's a 7. Right, next largest possible will be 8 here. Okay, I need that 5 to be the last digit in the ones place because that gives me a multiple of 5. Fill in 2 over here, and therefore the answer is number 1. Shrifen's score for maths improved from 50, that's the original, to 75. What's the percentage increase? So let's find out what the increase was. It went from 50 to 75. That's an increase of 25. Next, I want the percentage increase, which means that's the increase over what was before, the original score, 25 over 50. For percentage, we love our denominators to be 100. So times 2 times 2, we get 50 over 100. That is 50%. The answer is therefore number 2. Equal number of students in 6A and 6B, important to keep in mind. B to G in A class 6A is 1:2. All right, B to G in 6B is 1:3. Well, the totals are clearly not the same at the moment, right? This is a total of 3, this is a total of 4. So let's reflect that 6A, BG 1, 2, BG 1, 3, total 3, total 4. But we are told that the total number of students are equal. All right, so let's make them equal. So what we can do is to turn them into a total of 12 each. And how do we do that? We multiply by 4, multiply by 4. So that gives us 12 units here. 3 and 9 gives us 12 units. Multiply by 3, multiply by 3, that's 12 units. And 4 by 4, that's 12 units. So now we have fulfilled the true statement up here. Equal number of students in 6A and 6B. So what can we do with this? Find the ratio of girls in 6A. This is where you have to focus your attention. The final ratio required is girls in 6A, which is this part here, girls in 6A, 8 units. Total students in A and B, that's 2 12s, isn't it? So that's 2 12s, that's 24. So 8:24, simplify, 1:3, the answer is 1. For this question, we first have to focus on the fact that we're interested in the side view of this. So what I want to do is to be able to draw and visualize the side view. So this is the bottom row here, that's 3. That's the second layer, also 3. And then the top here, there's a 1 right there. So the thing about this printout, it's not very clear. There isn't a cube here, actually. So this part here is empty. So there's 1 cube up here. But the side view looks like this. What is the greatest number of cubes that can be added to the solid so that the side view is not changed? Well, for sure, we can fill up the 6 over here. So we're going to have a 6. Then we can have a 3. So we can fill this space and 2 spaces in the middle here, the spine right here. Okay, so that's a total of 3. The total, therefore, is 9. And the answer is option 2. Nora and Ming baked some cookies over 2 days. On Monday, Nora baked 29 more than Ming. On Tuesday, Nora baked another 15 and Ming baked another 20. So some quantities were added for both girls. At the end of the 2 days, the number of cookies baked, Nora baked, was 3/5 of the total. Do take note that 3 units after that belongs to Nora, and the total was 5 units. Okay, let's do something about the first statement. Nora, 29 more than Ming. Nora, 29 more than Ming. What about after that, on Tuesday? So let's show that Nora baked another 15 and Ming baked another 20. Now, this is where things get a bit tricky. Nora, 3 units. The total was 5 units. Now, doesn't that mean Ming's units would be 2? Because the total was 5 after that. And another thing you can conclude, therefore, is that if this is 3 units and this is 2 units, the difference must therefore be 1 unit. And that we can find by taking 29 plus 15 minus 20. That would be the difference here, which would be 1 unit. So 1 unit is 24. Take note though, 1 unit is not this blank space here. No, it's not. Okay? 1 unit is talking about this part here. Yeah? So 1 unit is 24. So day 1, Nora's baking on both days. Alright, so Nora baked for both days. That's everything here. That's a total of 3 units. So since we know that 1U is 24, 3U must therefore be 24 times 3, 72. The answer is number 4. Christina bought 5 pens at this amount each. So 1 pen is 275, 5 pens, we're going to multiply by 5, yeah? So we're going to take 275 times 5. You can do your vertical multiplication, but another way of doing this is, how about take 2 times 5, that's $10. What's 70 cents times 5? That's $3.50. And 5 cents times 5, that's 25 cents. Then from here, okay, add them all up, 13.50, and of course 13.75 will be the answer. The mass of a tennis ball when rounded to the nearest tenth is 58.0 grams. So to the nearest tenth, that's where the digit 0 is right now. What is the smallest possible mass of the tennis ball? So rounded off to the nearest tenth. I'm going to list a few numbers, okay, and let's see. We want the tens place to be as small as possible, sure, but we have to have it round up to 58 when rounded off to the nearest tenth. And the one number that can do that for us is 57.5. So 5 will be rounded up to 58 to the nearest tenth. Okay, we don't want 0.6 because we want the smallest as possible. We don't want 0.4 because that doesn't round up to 58. So the one that does it for us is 57.5. Question 18, order of operations. So the first thing we can do is to do that subtraction within the parentheses. Okay, that's a 24. Next, we're going to do multiplication first from the left to the right. So 5 times 24 gets us 120. Keep this division by 6 and plus 27. Next, let's carry out the division. That gives us 20. And now finally, we'll do the addition, giving us 47 at the end. Next up, AC and BE are straight lines from there. Okay, so we've got a right angle right here. So we want EFB, which is this angle. So we know that this EFC is 122, this part here. Why? Vertically opposite angles. So this part here is 122. So basically, we're taking 122 minus 90 degrees there. And the answer is 32 degrees. So here we've got 2 sides of a trapezium. The length of XW to YZ is 2 units to 5 units. Right, so the first thing I notice is we are going to have at least one pair of parallel, one pair of parallel lines only. It's a trapezium. Alright, so next, I've got XW as 2 units. So what I can do is think of this as 2 to the right, 1 up. 2 to the right, 1 up. So this is the 2 units right here, which means 1 unit is basically 2 to the right and 1 up. For YZ, we will have 5 steps. So 2 right, 1 up, 2 right, 1 up, 2, 1, 2, 1, 2, 1. So this is the 5 units that we're talking about. So from here, we can fill in the lines and get our trapezium right here. So join up, and then this is, don't forget to label, point Z. Yeah, and that's it. Muffins are sold in boxes of 1, 4, or 6. So we're assuming here that they don't want to sell boxes with empty slots. Yeah, so it's either 1 muffin in the box, 4 in a box, or 6 in a box. Tammy bought 45 muffins. What's the least number of boxes? Very important, least number. Okay, let's figure this out. Let's assume we are interested in boxes of 6. Yeah. So how many boxes of 6 will there be? 45 divided by 6. We get 7 full boxes of 6, and a remainder of 3 muffins. So I can buy 3 more boxes with 1 each. So the total number of boxes here will be 7, with box of 1, box of 1, box of 1. That's a total of 10 boxes. Now, it's not that easy, is it? So my spidey senses went up. What if there is a way to get even fewer than 10 boxes? So let's try another combination. 45 is made up of 6 sixes and 9, so 36 plus 9. Okay, so I'll need 6 sixes, 6 boxes of 6. What about this 9 over here? I can buy 2 boxes of 4 and 1 box of 1. Now that's a total of 6 boxes plus 3 boxes here. Box of 4, box of 4, box of 1. Hey, I've got fewer than 10 boxes. I've got 9. So the answer is therefore 9 boxes. A train left A at 10:30 p.m. and reached B at the next morning, 8:25 a.m. So how long did the journey take in hours and minutes? So let's make sure we underline the special requirement. We need to express in hours and minutes. So let's have the timeline here. In 24-hour timing, that's 22:30. Well, to get to midnight, that's an hour and a half. And then to get to 8:25, that's 8 hours and 25 minutes exactly. So let's sum up the duration there. So that's 9 hours and 55 minutes. Mr. Wong bought 576 roses. Reds to whites 3:2, whites to pink 1:2. So we can combine the ratios here and have this: reds 3:2, and then whites to pink 1:2. So this shouldn't be 2 and 1. Let's make them the same. We're going to multiply by 2. Multiply by 2. We've got 3:2:4. All right. Knowing that the total was 576, so we can say 3u plus 2u plus 4u. That's a total of 9 units is equal to 576. For 1 unit, we're going to divide by 9. So you can use long division or just split it up to 540 and 36. That's a total of 64 for 1 unit. How many pinks did Mr. Wong buy? So we're interested in 4 units, not 2, 4 units. So for that, we're going to take 64 multiplied by 4, which gives us 256 for the answer. A rectangular container measuring this by this by this is filled with water to a height of 12. So it's not the full height of 30, it's only up to a height of 12. So what's the initial, how much for? More water is needed. Okay, so if the height of 12 is already filled and the total height is 30, we can say that therefore the height to fill will be 18 centimeters. All right, so how much volume of water is that? So that's going to be 60 by 20 to a height of 18. From here, you can use your vertical multiplication. For me, I don't like to deal with zeros. It's unnecessary. So ask yourself, what's 6 times 2? That's 12. Add 2 more zeros. That's 1200. From here, that is basically, I'm going to take 18 times 12. Leave the 2 zeros outside. 18 times 12. So I know that it's basically 12 18s is 10 18s and 2 18s. Sum them up. So it's 21,600 cubic centimeters. Of course, this speeds me up for working with paper 1. By all means, feel free to do your vertical multiplication. So when it comes to this kind of question, usually the first thing that I do is to figure out what's how many ml per step. Let's count the spaces. 2, 4, 6, 8, 10. So that's 10 units for 1 liter. So basically it's 100 ml per step. Next, this is 100, 200. So 1 step here, 2 steps here represent 100 ml, which means 100 ml lost here will decrease this by 1 step. The water line will decrease by 1 step. But adding 100 ml here means the water level goes up or down by 2 steps. So it's not as simple as saying, you know what, I want the volume to be the same. I'm going to just sum up the volumes and divide by 3 and figure out what the height is. It's not as simple as that. Okay, so we have to do a bit more work, therefore. So for me, I employed guess and check. So let's assume we are going to decrease by steps of 100 ml. Yeah. So if I decrease 100 ml here, we're going to go 1 step down. Now let's say we gave this 100 ml to container B, right? Let's add this to container B. Remember, 2 steps here represent 100 ml. So it's going to go up to this level here, 300. Next, let's try decreasing by another 100. Now, if I give that whole 100 to container C, it's going to increase by 2 steps, which won't even be on the same level as container B. Container B is currently at this 300 mark over here. So how about we split that 100 into 50-50? So if I add the 50, I will go up by 1 step. If I add that 50 here, it will go up by 1 step. And what do you know? Container A is currently at the same level as the 2 other containers. So how much volume is left in container A? That would be one step, okay, that's 900 at the beginning. So if I subtract 200, so initial volume was 900. After subtracting 200, we get 700. That's the volume water left in A. Tricky. So we've got pie charts. 2/5 of the pupils obtained grade B. Well, this is 2/5, which means the rest will be 3/5. However, I don't know what D's portion is. A and C are both 90 degrees each. If you recall, a full circle is made out of 360 degrees. So that tells me that A and C, since they are 180, these two must add up to therefore be 180. Now, does that not tell me that A plus C is exactly the same as B plus D? So, with the information that B was 2/5, okay, oh, by the way, this also means this is half. Half, let's call it 5/10. 2/5, let's call it 4/10. Now, that tells me that this must also be 5/10, since we've got 5/10, 5/10. Then therefore, this must be 1/10 for D. What fraction obtained D? The answer is therefore 1/10 right here. Okay, folded paper question. Now, try with a foolscap paper, which is a rectangle, to go from one corner to the other corner. It is not possible. Yeah, it will not be able to be folded like this. Yeah, the only way this can happen, going from this corner, pulling it down to this corner, is if it's a square. So let's do that. So I'm going to fold from this corner to this corner, and basically what that means is I have half a square right here. So if this is 8 centimeters, knowing that it's a square, this must be 8 centimeters. Since this is 14, we can find out what this length is, which is 6. Okay, next. We've got a square up here. We can go from this corner to this corner, which means we've got a quarter of a square here. All right. And if we take this portion and fold it down, this is basically symmetrical, which means this is also representing 1/4 of this square. Yeah. Since we know that this is a square of 8 by 8, 64 square centimeters, and this is 1/4. So what's 1/4 of 64? That is 16 square centimeters right here, which is the area of the colored triangle T. Now, what's the area of the whole piece of paper? That's easy. That is 14 by 8. So the required fraction will be 16 over 8 times 14, the rectangle's area. Now, if you simplify 16 and 8, you get 1 and 2. So basically, that's 2 over 14. Joanne spent 1/4 of her money on a watch and 1/6 of the remaining. Oh, fraction of something, fraction of the remaining. This is a branch method question. So let's have the diagram, shall we? 1/4 on the watch. The remainder is 3/4. Of this remainder, 1/6 on shoes. The remainder, therefore, is 5/6. And this represents the 125.5 left. Okay, let's form an equation, shall we? So 5/6 of the remainder, therefore, here is 125.5. Okay, 1/6, therefore, we're going to divide by 5 because it's 5 units to 1 unit. That's $25.10. Okay, let's find these two branches add up to be 6 over 6. Okay, what's 6 units therefore? It's 150.6, which means this is 150.6, this 3/4 right here. So that tells me that the 3/4 of the total is 150.6. 1 unit is therefore 150.6 divided by 3 units to 1 unit. And how much did the watch cost? Hey, it happens to be this 1/4 of the total here. So that is $50.20. Quite a cheap watch. Alright, for graph questions, the first thing I like to do is to figure out the numbers that I'm working with. So count the steps is 50 each, and we've got 250 and so on and so forth. Okay, the average from Monday to Tuesday, okay, was the same as the average from Wednesday to Friday. Well, we can definitely find out the average from Monday to Tuesday. So 250 plus 350 over 2 days, that's 300. Since the average is the same as Wednesday to Friday, that means the 200 on Wednesday plus the unknown Thursday, Friday, divided by the total of 3 days, must therefore be equal to the same average, 300. So from here, we can form an equation, and therefore divide by 3, bring it to the right-hand side, we're going to multiply by 3, so that's 900. So positive 200 goes over to become negative 200, that's 700. The question would like the total Thursday and Friday, therefore that leaves us with 700. So the diagram shows 4 different triangles. Well, let's take a look here at the triangle, shall we? BC is the base. and has a height of 3 units, but at the same time, look at BCD, this triangle right here. It also has the same unit because it also has a base of 4 and a height of 3, just like BCA or ABC. In fact, the other triangle is also the same. Look at BCE, same height of 3, same base of 4. Okay, so take note of that. Now, the first statement is that ABC is of an area of 6 square units. Well, that's definitely true. So focusing on ABC, base of 4, height of 3. So half times 4 times 3, that's 6 square units. Fine. Absolutely true. Next one, twice the area of BCD is 9 square units. Twice the area of BCD. So for BCD, it is also 6 square units, and twice of that is 9. It is not, twice of that is 12 actually, it's not 9, so that is false. So recall that BCE has a base of 4 and a height of 3, which means it is also 6 square centimeters in area. Alright, so that's 6 square over here, right? So if this is 6, BCE is 6, this must be 18, isn't it? So 6 is to 18. Now, does it simplify to become 1/3? Absolutely. So this is 1/3. Next up, let's try finding the area of BFE, shall we? So that's a base of 2, 4, 6, 8, 10, 12, height of 3. So BFE is therefore half times 12 times 3, half times base times height, that's 18. So since we know this is 6, this is 18, let's simplify. It's 1/3, 1:3 I mean, okay? And that is true. It is a ratio of 1:3. So the first thing I will do is to show that, okay, we don't know what's at first, but we know that Kristen gave 18 to Lauren, so minus 18 plus 18. The end, Kristen had 1U plus 21 and 1U for Lauren, 21 more than Lauren. The total doesn't change though, because it's an internal transfer. Yeah, so no stickers were lost, no stickers were added. So we can therefore form an equation. Oh, by the way, please know that to find Kristen at first, you just take 1U plus 21 plus 18, yeah? So basically reversing that giving away of 18. So plus 18 would be the total at first. Anyway, we can form an equation. So 2 units plus 21 is equal to 85 as evidenced here. So from here, just take that positive 21, bring it to the right side, minus 21. That's 64 for 2 units. 1 unit is therefore 32. Okay, next up. How many stickers did Kristen have at first? Since we know 1U is 32, Kristen at first would be 1U plus 21 plus 18. So let's do just that. So 32 plus 21 plus 18 gives us 71. Question 2, we've got a square with a diagonal drawn. So we've got 2 45s that we know. In fact, let's do that. Diagonal of the square, we get 45. So let's draw 45 in the diagram right here. 45. Okay, we want T, yeah? So what if you know exterior angles of triangle, you know that this angle plus 45 must give me 122. By all means, use 180 minus 122 to get this angle and then use sum of angles in a triangle. But external angle of triangle is a shortcut here. So we know now it's 77 over here, which means angle T can be found by taking 180 minus 77. We've got 103 for the answer. Okay, find the area of ABCD. By all means, you can find the areas of 3 different shapes, but there is a much faster way of doing this. How about we fill in this area here and make it so that it is a rectangle 16 by 12. Well, another thing we can find out is 12 minus 9, we get 3 cm. So this 12 here minus 9 gives us this height of 3 centimeters here. Okay, let's find the area of the entire shape, shall we? That's 16 times 12, that's 192. Okay, let's take the larger area minus the smaller area, which is the purple triangle there, which is half by 16 by 3, the purple triangle. And that gets us 168. So we don't have to find the area of 3 different shapes. Just take the larger area minus the smaller area. Okay, let's just read this question really carefully. And fill in the information that we know for sure. Yeah, so we've got the right angles, that's very clear. We've got the 90 degrees folded here, rectangle 90 degrees here, folded over to be at this location. So AE is 3 units, so AE is 3 units, BE is 5 units, and BC is 4 units. Now because it's folded like that, right, the 4 units applies here as well. Well, we know for sure 3U plus 5U is 8 units from end to end over here. Now, next thing, DE is equal to EB. DE is equal to EB. Therefore, this is 5 units, this is 5 units. Hang on, if this is folded area, folded here as 8 units, folded up there, doesn't that tell us that this is 5 and 3? This part here, EC, is 3 units. Okay, because this is that 8 units over from here. Alright, so anyway, we've got quite a bit of information there. Find the area of triangle EBD. Well, that's quite easy, isn't it? So triangle EBD is therefore half times base of 5 times the height of 4, EBD right here. So that's 10 units, 10 square units. The area of triangle BCE is half times the base of 4, okay, times the height of 8 minus 5. That's 3 units here. Okay, so that's 6. So therefore, what's the ratio that we need? Okay, it's 10 is to 6, which is 5 is to 3. That's the answer. Okay, for such questions, as usual, I try to find out what's the value for each step here. So that's 2, 4, 6, 8, 10. So that's 1 for each step, which means this is 32. Okay, this is 2 fewer than 50. 2 fewer than 50, that's 48. This is 3 fewer than 30, so that's 27. This is 2 fewer than 20, so it's 18. Write the numbers down. Okay, from here, let's go. Each student borrowed either 1 or 2 storybooks. Hang on. If you sum them up together, you will realize something is really strange. We've got 125 books, but only 80 students. So if each student borrowed 1, you should have only 80 books, right? If each student borrowed 2, you've got 160 books. So we've got fewer than, so not everybody borrowed 1 or 2 books, yeah? And the way I choose to approach this is to assume first that everybody borrowed 2 books each. Then we would have 0 pupils borrowing 1 each, and all 80 borrowing 2 each. The total books borrowed would therefore be 160, 80 times 2. Okay, let's guess and check, shall we? So if you decrease this number by 1, you have 1 student borrowing 1 book. So the total has just decreased by 1. Alright, this is 159. So let's say minus 1 again, 78 students borrowed 2 each. Now there are 2 students who borrowed 1, so it's a total gonna decrease by 1 again. Alright, so I want eventually the number of total books borrowed to be 125. So how many steps of 1 do I need to take? That's a total of 33 steps. Alright, so let's do this. Minus 1, minus 33. So that's 45 right here. And we're going to add 33 here. That's 35. The question wants us to find out how many students borrowed 2 books. The answer, therefore, is 45. So question 6, 750 total at the fun fair. 30% were girls, the rest were boys. Well, we can instantly find out the number of girls and boys at the beginning, can't we? So we can find out that is 30% of 750, that is 225, right here, girls at first. 70%, right? 30% girls, 70% boys. So that's 525 at the beginning. Some girls joined the fun fair, so I don't know what's the addition here, right? And the percentage of girls increased to 40% of that new total. We don't know what the new total is, but if you tell me 40% were girls, that automatically means 60% were boys. Now, with boys being unchanged, we can therefore say 60% of that new total is 525 students, which means we can find 40% of that new total, which is 350. Now, since we know the girls after is 350, we can find out exactly how many girls joined. Since the beginning, there were 225 girls. So the answer is therefore 125. Alright, here we've got a unit and quantity question. The first thing is I'll get the model drawn out. Apple, each of them cost 50 cents, so let's write that down. And each orange was 40 cents. Next one, the quantity. The number of apples to oranges bought was 5 units to 2 units. Okay, so here we go. What's 5 units times 0.5? So that's basically 2.5. And what's 2 units times 0.4? That's 0.8. And now we are told this costs a total of $23.10. So let's form an equation here. 2.5 units plus 0.8 units, that's 3.3 units. That's $23.10. 1 unit, we're going to divide by 3.3, that's 7. How many apples did he buy? That's a total of 5 units, so that is 35 apples. Okay, Mrs. Tan had 47 kilograms of soap mix. 5/8 kilograms of soap mix was needed to make each soap bar. So, as many soap bars made as she could. Right, so basically the question is how many of 5/8 kilograms are there in 47 kilograms? That is a division problem, is it not? So, how many 5/8s in 47? So, we'll take 47 divided by 5/8. Okay, the answer from your calculator will be this, but what does that actually mean? It means that we've got 75 full packets of 5/8. Remember, we are asking the question, how many 5/8s are there? So with the quotient being 75, that represents 75 full packets of 5/8 kg. Then what does this remainder mean? Do not, like most students, write the answer as 1/5 kilograms, because this 1/5 does not represent kilograms. It does not. Okay, this represents 1/5 an incomplete packet of 5/8 kg. In fact, it is 1/5 of a 5/8 kg packet. That's what it represents. Okay, what is the mass of that then? It is 1/5 of 5/8. Okay, and therefore the answer is 1/8 kilograms. That's the remaining. Well, the first question here is a giveaway. What's the average soap from March to May? Well, March to May, sum them all up, divided over 3 months. The average, therefore, is 98. The average number of pen sold from March to July, oh, we've got 2 more months now, right? May, June, July, 2 more months. The average was 15 more than the average of pen sold from March to May, the number that we had just found. Okay, so let's do that. From March to July, therefore, would be 15 more than March to May. That's 113. But that's over 5 months. So we can find the total then from March to July, which is 113 times 5, 565. Okay, so what's the total from June and July then? For June and July. Well, that's subtracting everything here, isn't it? So we're going to take 565 minus that, that's 271. So write down a possible pair of values for the number of pens sold. Well, one possible pair could be 100 and 171. As long as the total is 271, that's fine. So AEF is an isosceles triangle. Let's reflect that, where AE is equal to AF. So we've got 135 here. All right, fine. We've got 102 here. This is a parallelogram. Oh, by the way, 135 here is this part here, yeah? It's not this angle here. It's this angle here. But we know for sure what is this angle because this is a parallelogram. They add up to 180. Anyway, first step is I'm going to find what CBE is. CBE is here, which is 180 minus 102. This is 78. This angle is 78. Okay, since this angle is 135, we can take 135 minus 78, giving me 57 here. All right, so this is a useful 90 degrees. So AEB is therefore 180 minus 90 minus 57, giving us 33 for the answer. So we've got a total of 380 reds and blues. After 5/8 of the red, we don't know how many reds there are, but 5/8 units. And 1/4 of the blues, we don't know how many blues, but total of 4 units of blues were taken out. There were 177 left. So I can form an equation here. Knowing that the total red marbles was 8 units at first, we can say 8/8R, and 4/4 blues is 380. So this was the number of marbles at first, yeah? Now, 5/8s were taken out, which means 3/8s were left. So 3/8R. 1/4 blues taken out, 3/4 blues left. Summed together, that's a total of 177. Now, the fact that this is 3 units of R and 3 units of B is very nice because if I divide by 3 throughout, I get to say that 1/8R plus 1/4 B is 59 in total. Which means I can multiply by 4 on both sides. So this is 4/8R, 4/4B, 236. I'm going to call this equation 2. Now, why is equation 2 important? Look what happens when I take equation 1 minus equation 2. Well, 8 units of R minus 4 units of R is 4 units of R. 4 units of B minus 4 units of B, that's 0. So we have eliminated B basically. And we can take 380 minus 236. So the result looks like this. 8/8R minus 4/4R is 4/8R. 380 minus 236 is 144. And B was eliminated. So we can therefore say that the total R's at first was 288, which is what the question wants. How many reds were there at first? That's 288. Whenever I see the word rhombus, I will mark out the four sides as being equal, which basically means I've got two isosceles triangles here. Now, 35 degrees here means 35 degrees here. Well, ABG, right? The first thing I focus on is triangle EBC, okay? So, if I take a look at 154 here, I can tell with this 78, I can find this angle here, which is the blue angle, 76. So 154 minus 78 gives me 76 here. External angle, exterior angle of triangle. Okay, knowing that this is 76, what's angle ABG? ABG is this, yeah? Which means 76 plus 35 will get me 111 as the answer. Next up is EFD right here, EFD. So what we can do is to basically say, all right, so these two are vertically opposite angles, which means these two angles are the same, which means I can say the fact that I've got a quadrilateral here, which sums up to be 360, I can subtract these three angles and get the fourth angle here, which is exactly what I'm going to do. All right, so I'm going to take 360 minus the three angles and get 139, and that's the answer. Question 13, the graph shows the cost of hiring a minibus from a transport company. So the charges here are shown in dollars on the y-axis. Next, on the horizontal axis, we've got distance traveled in kilometers. The distance from A to B is 6.2 km. What is the cost of hiring the bus from A to B? Now, before we start, I usually like to begin by writing some numbers down. So read the graph and find out that, okay, for the first 10 kilometers, it's a flat rate of $50. After the first 10 km, and then it goes up like this all the way to $80. So write the numbers down. Okay, now since 6.2 km is less than 10 km, so it falls within this range here, and therefore the charge will be $50. That's the first answer. Mr. Tan hired a bus to travel from C to D and back to C using the same route. He paid $90. So it will be useful to look at the graph and see $90 corresponds to a distance of 30 km traveled. So a total of 30 km is traveled. Now, but this is basically covering 2 units, yeah? So C to D and back to C again. So 2U is basically 30. So one way it must be 30 divided by 2, 15 km. How much does the company charge for every km of travel after the first 20? So we are interested in this straight line up like that. After the first 20 kilometers, there is this slope going up. And it's the same slope. Look at this. This is 1 unit right, 1 unit up. 1 right, 1 up. 1 right, 1 up. 1 right, 1 up. So it's increasing at the same rate, basically. Which means we can find out, we can use this part or this part or this part. It doesn't matter. Okay, so let's see. Let's use this part. 90 minus 80, that's 10 kilometers traveled. And that will be an increase of $10. Why? Because we go from $80 to $90. In other words, the $10, it will be $10 for 10 km. And that comes down to a rate of $1 per kilometer, just divided by 10 on both sides. The table shows a set of numbered cards distributed among 4 boys, Alan, Brian, Chris, Daniel, who will receive the 29th card. The easy way to do this question is to keep on listing 17. So it goes like this, yeah? 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. So it's basically snaking, yeah? All right, so who will receive the 29th? Like I said, the slow way to do this is just to go and complete the snake. 18, 19, 20, 21, 22, 23, 24, and so on and so forth. You can also do it using division. So I treat this coil here, right, as one group. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8. That's one group. And then the same pattern is repeated. Go to the right. 9, 10, 11, 12, 13, 14, 15, 16. So I consider this as the second group. So each group contains 8 numbers. So how many groups of 8 are there in 29? So the answer is 3 complete groups and a remainder of 5. In other words, in the 4th group, it will be 1, 2, 3, 4, 5 in this column here. So that means that will be for Daniel. Next question. All the cards in the set are distributed. Each boy receives an equal number of cards. Okay, so this basically shows Alan having 1, 2, 3, 4, 5 cards. In the end, each boy receives an equal number of cards. So this must be the same number of cards. If it's 5 here, it must be 5, 5, 5. Yeah. The numbers on the cards for each boy add up to 132. Now what they mean is basically each card has a number and the face value added up must be 132. So this is 1 plus 8, that's 9 total face value, plus another 9, that's 18, right? And so on and so forth. Just keep adding up. Of course, the slow way to do this, oh, by the way, all of them add up to 132. So everything 132, 132, 132, and the number of cards must be the same. So basically, I just decided to focus on Alan. It doesn't really matter. You can focus on B, C, and D. For me, I chose to focus on Alan's case. Right, so start off with 1. That's 1 card. Total face value of 1. Okay, next number is 8. So there's a pattern here. Plus 7, plus 1, plus 7, plus 1, plus 7, plus 1. And keep adding up, totaling up the face value of the numbers. So 1 plus 8, that's a 9. Add another face value of 9, that's 18. We are going all the way until we get the number we want, 132. And we realize here that's 8 cards for Alan. 2, 4, 6, 8. In other words, B, C, and D also have 8 cards each. So the question is asking how many cards altogether. We have 4 boys, 8 cards each. That will be 32. Joanna paid 126 for a bag after a discount of 25%. What was the price before the discount? So basically this 25% off means 75% paid, and we are interested in 100% before the discount. First step will be to say that 75% of the usual price is 126. For 100%, you will take 126 divided by 75 to find 1%, and then multiply by 100% because that's what we want, and we will get $168. Paid a discounted price of this for a pair of shoes. The total discount for the pair of shoes and the bag was $61.20. Hang on, we can actually find the discount for the bag, can't we? That's 25% of this number. Okay, so let's start off with that. The discount on the bag is 25% of 168, that's $42. Since the total discount is $61.20, subtract that and we get the dollar discount for the shoes. So the percentage discount, well, this is the discount out of the usual price. What's the usual price? The discount is $19.20. The usual price is the sale price plus the discount, and then out of 100%, the answer is 15%. Ben had some red, blue, and yellows. He had 156 more blues than reds. So I'll hold on to this because it's not that useful to me just yet. This phrase here is much more actionable. 2/3 as many yellows as reds. So I can conclude from this that there were 2 units of yellows and 3 units of reds. So let's draw what was the situation before, what the situation was before. 3 units for reds, 2 units for yellows. And now I can act on this. 156 more blues than reds. So whatever reds are, add another 156 to them. Next, he gave away 1/3 of his reds. Now, 1/3 of 3 units is a nice 1 unit. Okay, so that's fine. 5/6 of his blue is given away. Now, 5/6 of 3 units is not going to give me a nice whole number. Yeah, so I can do something. I can multiply each 3 units by 2, okay, and get 6u plus 156. And I have to do the same for the yellows. I've got 4 units here, so that the relationships do not change. They still hold true. Still 156 more than R, still 2/3 here, the ratio. Okay, now the advantage is 5/6 of 6u. It's really easy to find out what that number is. Okay, now 50% of the yellows, this is an even number, so halving it should be easy. So give away 1/3 of his reds, remaining 2/3 of his reds left. So what's 2/3 of 6u? That's 4 units. Give away 5/6 of his blues, meaning 1/6 of his blues left. So what's 1/6 of 6 units? Right, that's 1 unit. What's 1/6 of 156? That's 26 remainder. Next one, half of his yellows gone means half of his yellows left. In the end, this is going to represent all together 250 actual cards. From that, we can form an equation. So 2 units plus 4 units plus 1 unit plus 26 yields 250. Combine the units, we've got 7u plus 26, positive 26, negative 26 on the right side. Next one, we can find 1 unit being 32. How many cards did Ben have at first? So all the cards at the beginning. Note, we are not using this anymore. 2U, 3U, 3U. No. We're using this. So that's a total of 16 units plus 156. So if 1U is 32, then 16U will be 32 times 16. Adding that 156 will give us 668 for the total card the Ben had at first. How many blues did Ben give away? How many blues did Ben give away? Look at this. We can find the difference precisely. So what is 5 over 6 of 6U? That's basically 5U. What's 5 over 6 of that real number? That's 156, yeah? So 130. 5 over 6 of 156, that's 130. Now add them up together. Now we know that 1 unit is 32. So 5 units must be 5 times 32. Add 130 to it, and you get 290. An open rectangular box is shown below. Oh my goodness, the word open is extremely important. Why? Because when we consider the total area, we will not factor the top to 54 on the top, yeah, because it's open, it's not covered. Well, the outside of the box, including its base, is painted. Find the painted area. Well, we will have two 27s back and forth, two 18s left and right, and the bottom part, 54 square centimeters. And that's what we'll do. We'll add up two 27s, two 18s, and 154, getting us 144 square cm. The box is packed full with 1 centimeter cubes. What is the least number of cubes used? For that, we have to find out what the length is, because there will be 1 cm, 1 cm, 1 cm all along the length, and 1 cm, 1 cm all the way along the breadth and the height. Yeah. So we need the lengths. However, we are not given lengths. We're only given areas. So what we do at this point is to list the factors of each of these numbers. And let's see how that works, shall we? So with 27, we've got factors 1 and 27, 3 and 9. Now, what 3 and 9 are useful because I can say, all right, so let the height be 3 and the length be 9 here. What's cool about 18 is that it also has factors 3 and 6, which means the length could be 6 and the breadth could be 3. And this is important because the height has to be the same number, in this case 3. This works because 9 times 6 does give us an area of 54 up here. See, length 9 times breadth 6 gives us the top area 54. Alright, so this combination is what works. Next, so along the length, we've got 9 1 cm cubes. Along the breadth, we've got 6 1 cm cubes. On the height, we have 3 layers of 1 cm cubes. So basically, all the cubes will be 6 times 3 times 9, giving us 162. That's the number of cubes. How many cubes touch the inside of the box? Now, let me illustrate this in a different way. By the way, it's an open box. So the inside of the box, what do they mean by that? So this part basically refers to the cubes, all 7 of them, having contact with this side of the box. And these 4 having contact with this side of the box. And of course, we've got 1 of the cubes in each of these corners. And where did I get 171 from? It's basically from the fact that the length here is 9. So basically, we've got 1 for the corners, and 7 in between, for a total of 9. For this side being 6, we've got 1, and a 4. Yeah, and we've got a layer that is 3 deep. So the top layer, therefore, how many in contact with the inside of the box? We've got 2 9s and 2 4s here. Okay, that gives us 26. For the middle layer, it will be the same 26. The bottom, though, will come in contact with the bottom. So basically, that's the entire row, bottom there. 9 times 6, 54. Add them all up, and you have 106 cubes making contact with the inside of the box. And congrats, you have come to the end of this paper. Hope you enjoyed it and learned something. Take care. Bye.